Hello, everybody, and welcome to our 46th episode of our webinar series here at aimsports on our LearnFast program. Um, we're going to talk about something today that I've been asked about quite a bit, and it's one of those that we almost have to build some background into it, which we've done a little bit with some of our other webinars, and it's time to attack this a little bit. We may need to do a part two. We'll have to see how it kind of works out. But we're going to talk about suspension analysis today, and we're going to dive into it. We need to set the table a little bit, so there will be a few slides in the presentation here before we get into some live data, just to kind of set the idea and make sure that that you get good data out of your suspension analysis, and that's kind of an important thing. The first thing I'd like to do is we normally have a lot of AIM staff here, and it's that time of the year. Boy, we're out there supporting and working with you guys as much as we can. Literally every employee that has been here from the AIM Sports North America side is on the road at racetracks today. So I am super pleased and lucky that we have Emiliano here from our Italy main office, and he's here to help you in the background. He's going to answer some of the questions, and I really appreciate him taking his late night to come here and join us for a lot of these webinars. It's very appreciated. And at the end, we're going to announce our next webinar. Please stick around for that. I think you're going to love that one. It's going to involve Emiliano with some things. It's going to be a little bit different, and we're going to need your help. So please, if you can hang around to the end, and help us with some ideas for this next webinar, please hang around. The suspension analysis. Let's jump in with just a little bit about me and why suspension is something that I have I really enjoy talking about and looking at. My background is in that upper left-hand corner is off-road racing. I did it for about 20 years. There is nothing more important in off-road racing than suspension. Things over there are a little bit different in that type of a world, or motocross, or anything that's jumps and bumps and those kind of things. So we have shocks in that world where certainly they're a high-end shock, but then they've got these bypass tubes. And when we started to use some data on some of the off-road trucks and buggies that we started to do a little bit of work on, we are changing not just the rebound and dampening, the rebound and compression, but also where it hits, and we're opening these little bypass valves, and it might be 3, 4, 5 stages where these shocks just keep getting at different rates as it goes through the entire process, which makes this data even more important, so we can capture that. Things are moving so fast when those things happen. Data and suspension, things are happening at a high rate of speed, so it makes it very helpful. So and then of course that same exact technology runs its way through either oval track racing, like in the upper right hand corner, or the road racing or circle track on the dirt, or whatever it happens to be. This is valuable information. It's one of those things, if you can't get the power to the ground, it's you can have all the power in the world and we're not making much movement, right? So please understand that we're gonna chat about that, and it's gonna be across all the different lines. We're gonna talk about the function. We're gonna talk about sensors and how to set them up, and this is one of suspension is one of those things where it's not like a water temperature or plugging in an oil temp sensor. It is something, if you put it in and attach it and then do a step wrong in between there in the software, it's bad data in, bad data out. So we need to pay a little bit more attention to how we set these up. And so we're going to talk a little bit about that before we get into the function itself. So let's jump in a little bit and let's see where it kind of takes us. First, let's talk about sensors. The ability to put these sensors on these cars and work with them is they're out in a vulnerable area, and the sensor is moving. Half of that sensor is moving like crazy, right? Because we're measuring suspension travel. It's not like you just put that again, that oil pressure sensor in there. You kind of zip tie the wiring off to the side and you isolate it from some vibrations, and we're off and running, right? It sits there forever. So these sensors here are in a way that you really need to mount them with some forethought and mount them carefully. you try to mount them out of harm's way as best you can. There is most all cases, they're out there, right? They're going to be out on the suspension. It's going to be moving up and down. There's places where there's going to be rocks and bits of rubber and of course crash damage and some other things. But do the best you can and try to get those things mounted in a way where maybe, yeah, like the picture I've got up there is, this is an MX-5 Cup car, and you've got some brake hoses and some other things that are around at the brake line. When this moves up and down, try to cycle it through where that hose is not rubbing into your sensor during the run. Make sure that brake line doesn't come over and get it. Make sure that it's clearing your anti-sway bars. All of those kind of things. Make sure that you understand that and make sure it's nice and clear. Okay. I've also had some people that have taken these sensors and they wanted to mount them in such a way that they got their information they were getting, it was in a positive was negative and negative. So they take and they mount the sensor upside down, and all of that's fine, and and maybe that's what they really needed to do. But then they now all of a sudden you've got all this extra weight of the body of the sensor, and this is the stationary end. And sometimes with when you get these, you hit a curb and you get the super high rate of speed, many millimeters per second of travel of the velocity. And when you're trying to move that entire big bulk of the body of the sensor, it ends up, you can break it, you can bend the shafts, you can do some other things. So it's always good to mount the light end on the suspension arm on that end of it, and get a good idea of what's happening. So keep that in mind as well. And then the other end is you've got you can't see it in the picture here, but you've got you've got the wiring harness coming out of it that's heading towards the data system. That thing there, if depending on where you mount these on the suspension, if it's some of the bikes and some of the off-road stuff, it's moving a lot. The travel moves a lot, and that sensor ends up rotating quite a bit, even at the top. It's a Heim joint. It handles it just fine. But now the wire is coming out, the harness is coming out, and if you wire tie that very tight, all of a sudden when you go to full droop, it starts to pull that wire. So little things like that. Mount. These are expensive sensors. They're very powerful tools, but take a little time and think about how you're mounting them. Certainly you're going to end up taking the spring off the car, off the shock itself or out of the system. Take the torsion bar off, whatever it happens to be, and cycle the thing the full direction. Make sure that this thing is mounted correctly. There are different sensor types. This is what we call linear potentiometer, and then this one down here at the bottom is a rotary pot. They're the rotary potentiometer. There are a number of different types. So there are even many more beyond that. I just wanted to give you a couple of ideas. There is this is a pretty inexpensive option for you. This is GM has had some that we've seen a lot of people use. Gosh, you can get them down in the 40, $30 to $50 range, and they're ride height sensors out of the late 2000s General Motors. This one happens to be a Cadillac GTS, but the Camaros, the Corvettes, there's a number of cars that had this type of a sensor. You just need to make a couple of some special mounts, and you stick them up in there, and then you're off and running. There are different sensor lengths. This potentiometer here might be 150 millimeter travel. If depending on where you're putting it, what you really kind of want to do is get that thing where it's using most of the sensor. There's a resolution issue that we want to make sure we're using the resolution as best we can. And if you mount that thing way up the arm and you're only moving that shock pot a half an inch, you're trying to use that that 0 to 5 volts, and you're only using a quarter of a volt to try to see everything that you're seeing. It's better to have that sensor moving more or less the full travel minus maybe a half an inch on each end or something, right? Something like that. So keep that in mind. Try to get the sensors. It's always a good idea to try, if you can, if your car allows it, to use the same sensor on all 4 wheels. That just keeps you your spare parts are just much less, and the same one can be used on the left front corner as it can on the right rear. And the other thing that some people will do is maybe you've got a gear position sensor that you can use a linear potentiometer on. Maybe your steering, if you got a rack, you can end up using the exact same sensor on all of these different things, and that will make your life a lot easier as far as being able to swap swap one out here and there. So keep that in mind on your different sensors. I see a question from Andrew. I haven't read through it totally, but I believe it's a sampling rate consideration kind of a question. Let's talk about that for a moment. We are going to be looking at data that happens in a very big hurry. We often will have things being sampled at 10 samples per second for maybe a temperature change. Maybe it's 50 samples per second for an accelerometer. Maybe it's 20 samples per second for a steering sensor. What you have to do is sit down and think about what all of your different sensors are, and think about how quickly does that particular channel change, and how fast do you have to sample it in order to gather the information you need about it, right? So so suspension is one that we just have to capture it at a lot higher rate, and in order to see all of those, see you catching the curb or hitting a bump, or make sure we see the roll of the car, and then we have to be able to measure fast enough and with enough of the travel to get some of these histograms and the velocities and some of the stuff we're going to talk about here in a minute. Typically, the data we're going to look at today was sampled at 100 samples per second. Most people will tell you that that's a little bit light, and I probably would agree with that. Kind of the baseline that a lot of people will say is maybe 200 samples per second. 500 is, and your AIM systems will do that. The 500 is probably, what any number of people will do. And then I know when I've done some work with some folks, NASCAR type circle track stuff, where they're taking that data and taking it right into some of the computer programs and and some of the things that they do to prepare their cars, and we had to do them at 1,000 samples per second, because that's what that particular hardware and data pieces that they were taking the data into really worked at that level. So figure out what you want. 200 samples is your normal every day, is probably going to be you're going to see most of what you need to see. So just keep that in mind. Okay. And then sensor calibration. AIM has a fairly easy process. When you get your car's on a flat plate, or you're on your scale pads, or you're just sitting in your paddock area where it's flat, you want, and I'll show you some examples of this in a moment, you want to zero out the sensors at the right height, you in the car, the weight, where you want them. You've adjusted all of your cross weights and all that stuff into it. You want to you want to then go ahead and calibrate out the sensors. Not going to go through that step today, but I'll show you the result of that in the data here in just a moment. But sensor calibration is another important piece of that. Several webinars, we've talked about some configurations and calibrations in the past. We've also, a couple of webinars ago, we did talk about how to adjust in the tips and tricks part 2, we talked about how to calibrate sensors after you were done. Let's say you forgot to calibrate, or you such a big hurry that you had to make an adjustment, went out, and maybe it's saying you're 1 inch higher than what you actually were. We can take that out. So check out some of those older webinars too. But sensor calibration is something that we need to do, or else some of the data down the road that we're going to interpolate through and do all this math on, it would give us some false answers. So I just needed to go through some of this to set the table that this is kind of an important thing for you. Okay. As usual, the data we're about to look at, the data, the math channels, the user profiles, and this presentation, Emiliano's been doing a great job as the link master over here in the chat, has been throwing some links up there, but all 4 of those things will be available to you either in the chat, or will be available to you in the description box when this gets to YouTube in an hour or so. So if you want to make sure you have some of these slides we've been looking at, and then of course the data with some with these sensors in it. In fact, it's the car that you're looking at right here is the data you'll be looking at, this MX-5 Cup car. And all the math channels that we're going to describe and talk about, and the user profiles to set your screen up in the way that we're going to look at it, will all be available for you to download from the description or from the links that Emiliano is taking care of. Okay. I think the last thing we want to talk about before we jump into some real data, this is that same car on the upper slide. This is a rear corner. And I got a slide down here at the bottom. I mentioned in the bullet points, bad data in, bad data out, right? If you don't take care of a couple of things that we're going to talk about here in the next in this slide, and then of course into the live data, you're going to be getting some false data, and you may not understand it fully at first. So the motion ratios. We need to talk about this because in our upper right hand corner here, we've got this MX5 right rear suspension that we're looking at, and you can see the blue suspension linear potentiometer over here. We wanted to get it out here, out of the way. It was a coilover that's really packaged tightly up in this area. I could not get that suspension sensor, have it be safe and have it be out of the way for all the adjustments we needed to do. I did not have the opportunity to put it in line with the shock absorber. So because of that, now this linear pot that we're looking at here and the data that's coming from it is not representative of what the shock shaft is actually moving. And this is a critical piece. We need to run it through, need to take that spring off and then bring this thing to full droop and take the suspension up an inch at a time and measure how much the linear pot is changing. The difference between those two is what we call a motion ratio. So when we get the data from the linear pot in our data loggers, right out of the linear pot, we then need to multiply that times a number. So then we're transmitting that information and applying it to how much the shock shaft is actually traveling. If we don't do that, all of these adjustments you're going to make, at the other end of this hose right here, there's a canister that has the adjustments for the rebound and compression dampening. If I am making adjustments on this inch of travel here when we're actually moving a little over 3 inches over here, we're gonna make some false choices. So we need to make sure we understand what the motion ratio is, or we can actually do it in if you're running through some bell cranks and some other things on different types of suspension. Maybe we even do it as a custom sensor because it's a rising rate or some other things. We have ways of doing that. If you have something you need to talk in detail with, get with me. This top sensor here, it needs a motion ratio. This sensor here is not traveling at the same distance as the shock shaft over here. We need to apply that. We're going to talk about that in a moment. The bottom one, you've got the sensor is mounted in line with the shock. It is up the arm a little bit, so there might be a motion ratio there a little bit. We would need to measure this to make sure. But typically, if you can get this shock, the linear potentiometer or the shock sensor in line with the shock, then that whole step goes out of the way and you don't need to worry about the motion ratios. But I just want to continue to mention them because it's something that's important to making sure we're transferring out to the shock shaft itself. And then one last thing is that motion ratio. We're going to have a couple of them here because there's things on the car that you may want to do, and I'm going to show you how we do them, is now all of a sudden we want to know what the pitch of the car is and the roll of the car front and back so we can understand how the anti-sway bars are working and some other things. So what we also need is another movement of how much the tire goes up and down, right? And then we need to know the track width and we need to know the wheelbase. And then all of a sudden we can do math where we know the pitch and the roll of the car based on the suspension compared to the chassis. And now this is really helping us do a lot of other things, but that's a separate motion ratio. So as we did what we mentioned a minute ago, we take the spring off, we go to full droop, we move the bottom of the wheel or the axle, middle of the axle, however you want to measure it. We move it up an inch and then we measure how much shock travel is moved and how much linear potentiometer is moved. And then after, we start to do that every inch of travel, and then we start to end up with a plan of what is our ratio to get from the linear pot out to the shock shaft and out to the wheel hub itself. Okay, so we end up with being able to fairly simply do the math to get shock travel and wheel travel out of this linear potentiometer that's sitting in here. Okay. All good. And then we're going to talk about the suspension analysis settings. I didn't want to do a bunch of screen captures, but I want to do that in the live data here. Okay. So then, so let's talk about one more thing before we get into the data, but we'll start here when we get in. I just wanted to show you guys that we have all sorts of little programs in Race Studio 2 and soon to be Race Studio 3 beta that I'm sure a lot of you have been working with. Where we can look at the actual data traces. Let's start off with just some basic damper position data. I've got a speed trace here at the top. It's just kind of my thing where I always have a speed trace so I can see if we're speeding up or slowing down. And then the next 4 traces here, I've got the left front potentiometer. That's the left front tire, what it's doing up and down. the right front, the left rear, and the right rear. This is just basic damper position data. We're not doing anything with velocities yet or anything. We're just saying, where is that pot? And this is the raw data from the pot. No motion ratios applied to it yet. I just want to show you what it kind of looks like. We typically zero at ride height. That's the way I like to do it. There are some people that will bring it up off the ground and they set zero there and some other things. But I'm a fan. It makes more mental clarity to me to have zero be here at zero. Okay. As this car is driving down the front straightaway, this is Utah Motorsports, the old Miller Motorsports Park in Utah. And so here's a long straightaway. And again, this is MX5 Cup data, not a ton of speed here, even though this is a long straightaway. You know, it topping out at what, about 115 or something like that, 113. But what's kind of interesting is here is what the car was seeing as the driver was driving up the front straightaway. The cursor here is part way through turn one. We'll look at that in some detail here in a moment. But one of the things I want to talk about is how do you read that trace? It's going to be important to you when the time comes to start looking at some data. This sample data is going to be available for you, obviously. What this is basically is the trace follows the suspension. I'm no engineer, so I have to kind of dumb this down a little bit for me to think about how that line, what does that line reflect? And one of the things that I like to think about it, the way I like to think about it, is if that line is going up above zero, positive numbers, is the tire is going up. The tire and the suspension is going up into the wheel well, right? If it is negative or dropping below the zero line, the tire is dropping out and going into droop, right? So that's how you can kind of read this, and because of that, we can see an arrow effect on the pitch right here. Let's just kind of focus our eyes here on this first little bit. The driver is driving straight down this long straightaway, getting some speed here towards the end. And if we look at, let's kind of focus on the left front pot first, you can see that the tire was down and the front was up. Just, you know, the nose of the car was slightly up. It's a little bit negative number right there. And as it's getting closer and closer to up to speed, you know, getting up above 112, 113 miles per hour, you can see that tire is going up into the wheel well, or the nose of the car is being pushed down. Right? And you can see it especially here on the right front. It started here and it's being pushed down into and being nearly zero just before he hits the brakes. That means that the car was nose high as it was coming down, and as it was slowly going down the straightaway, the nose was coming down. Let's look at the back as a comparison against that. Here, the tire is being pulled down, or the back of the car is coming up as it goes down the straightaway. So what we're seeing here is an arrow effect on this flat straightaway, that the nose, the back of the car is being brought up a little bit, and the nose is being pushed down just from the arrow. There is a little bit of downforce from the front, and probably without these cars ran without a top, so there's that big old, air compression, hitting down in the back seat area, and then that and there's probably a bit of a vacuum, and it's probably lifting up the car just a little bit. We would see a lot more change in this if you had an open wheel car, or a car with a big front splitters or wings or things like that. You'll see a lot more here. This is simply a production based, no arrow aids at all. So it's just the arrow of the car. So, okay, kind of a cool thing you can see on the pitch. And then what's braking do to the pitch? Again, I just want you to get this basic damper position, a feel of what we're seeing. The next thing is the driver comes up there and dynamites the brakes and getting ready for turn one, starts into this left-hander. Look at what happens, and we'll see it in full size here, maybe a little bit more, but you'll see that the left front, all of a sudden the tire gets packed up into the wheel well a little bit, just for a split second. The right front is doing the same thing. It gets packed up in. The rears are, the tire is dropping down and dropping down. And because as soon as the driver is coming along, hits the brakes, of course, it transitions and transfers the weight to the front, lifts up the back a little bit. And then so we can see that and how much that's doing it. It'll help us on maybe some compression dampening or rebound for the back to keep the car a little bit more stable, the platform, if that's what's important to you. The next thing we do is let's start on this right rear one. You can see that it went down, the tire drooped down, and all of a sudden it started back up. And what that is now we're seeing the turning effect on the roll of the car. While if we think about this is a left-hand corner, so this right rear tire is going to be, as soon as the driver is braking and starts that, some of the data we've looked at before in maybe some GSUM information, the driver hits the brakes in a straight line and then starts that transition into the corner. Now, all of a sudden that rear end had been up, but now he's starting to add lateral Gs to it. And now that right rear tire is being packed up into the wheel well. So you can see the transition from being down to crossing over zero and then being packed up into the wheel well as the car is starting to transition from longitudinal Gs to lateral Gs. And you can see that the inside tire, the left rear, it went down and stayed down. You can see where he probably has released the brakes here a little bit and the car is sitting there a little bit and then starts the process as he's opening his hands. The right front has been packed in from the brakes and then stayed there because he's, it's loaded on that right front corner and turning. And on the left front, it packed in when he hit the brakes and then transitioned into droop as it was going through the corner. Just an interesting things that you can see and how much it's moving. Gosh, you can see some spikes here all of a sudden in spots, and those are where he is maybe using a little bit of extra curbing, either at the apex, if it's on an inside tire, or at hitting something on the outside, and all of a sudden the suspension will come up on an exit curb. We can see how fast those things are happening. We can see how much he is using. There's some pretty big hits over here in this right front that goes up right up to the top of the travel window. Again, just all stuff that I wanted to kind of show you. We're going to jump into the live data right at this screen just to give you an idea of what this looks like, and then we'll transition into what I think most of you really are here for, which is the suspension analysis function in the software. But I think everything we're talking about here is are important things to set that table and get everybody ready to take that next step. I see a comment over here that talks about units. I happen to set this up as millimeters. It can be in inches. It can be in whichever unit you want. For me, with this particular car, we used millimeters, and it made sense for what we did. But it's the numbers, the traces will look exactly the same, and just the numbers will be in English units. So no big deal there. Okay, let's jump into some live analysis. Okay, let's new share, and let's jump into come on baby, there we go. And let me jump back into, let's jump into, I've saved some profiles here, by the way. Those are downloadable, will be downloadable now. Emiliano might make that available for you in the chat, but it certainly will be available. These three profiles will be able to be imported in and brought in. So when you're looking at this data, you'll have the same settings and everything that I am using here. So, I just went to traces. Let's go back to the measures. Now that we're in the live data, here's that exact same hitting the brakes process that we talked about, that we were just looking at in the screen captures. Here is the first thing I want to talk about is those math channels. I want to talk about what I showed with the pictures, where we have to get from the linear pot or the rotary pot or the sensor itself, and we have to move that out to get to the shock shaft travel or the wheel travel, right? And you can see a bunch of math channels that are in here. They're all available to you. They're part of the downloads of the math channels, and they'll be embedded into the data when if you grab this data as well from Emiliano's link or from the description box below. If you're on YouTube, here is the actual raw data coming from the potentiometers. Okay, left front underbar pot, right front, left rear, right rear. Then we have to do that math. Remember, we talked about the motion ratio to get over to the shock, because the shock is really the most important one when we're starting to look at the histograms and look at rebounds and velocities. That shock is where we're making our adjustments, as I mentioned before. I need to get to shock position, left front, right front, all the way around the car. Let's open up the math channels and show you what these math channels look like. We're not going to spend a ton of time here, but there's that left front shock position. We're taking the left front potentiometer raw data that's coming in. And like I mentioned, the left front pots were gathered at 100 samples per second. Probably 200 is probably what most people would think that you would probably want to do on a daily basis. Maybe a little bit more if you're really working on shock specific stuff or some of the bigger tools. But left front shock position, my motion ratio in that picture that we showed you ended up being 3.1 on the fronts, and on the backs it was 3.1. We spent some time to get those things to be as best we could, to be as even as possible. So we moved them up and down. If you remember the picture on the back, it actually had a clamp on mount, and we were able to move that around really quickly and use different holes to get these to all be the same. It just made it easier for us as far as our math and mentally. Right, but it doesn't matter. You can, if you ended up mounting it however you wish, you can have 4 different motion ratios for the 4 different corners. In my case, 3.1 times the shock shaft is moving 3.1 times more than the shock sensor. Okay, so because of this, we're taking every bit of raw data. We immediately just multiply it times 3.1. We're doing it at 100 samples per second. We use the same raw data sampling rate as the sensor was, so we're just matching it exactly. We want a couple of decimal places on the output, no filtering, and this is just the scaling and of course the units, what we're going to see. And we did that all the way through. So those are our 4 shock positions. I can then also come in and do a velocity right here in our measures graph. So I took that left front, and I don't care about the velocity of the shock sensor, correct? What I really want is the velocity of the shock position. So if you look at our derivative to get to the histograms and the velocities, the shock position left front is the value I'm using. I'm not using the raw data from the pot itself, from the left front potentiometer. I'm using what's already, the math has been done to stretch out that distance, and then take the derivative of that to get the velocity of the shock, of the actual shock shaft. Then I've got a suspension position left front, another math channel down here, where I take the raw data from the pot for the potentiometer, and then in this particular case, it was 1 inch of travel of that shock sensor was 10 inches of travel out at the tire. Okay, on the front, and on the rear it was 7.5. It's just the way that it ended up being mounted, where the shocks were compared to the pots and where the suspension travel was. These are all things you're going to have to do for your car. You can't use these numbers. You have to just cycle it and figure out what it is for you. Okay, so now I've got a suspension position out there at the outer edge, right? And now I can look at the track widths and the wheelbases, and I can actually see what the suspension is doing based on this math. Okay, and a few more things, and here's the front roll, and I can take and do the math and end up with, by plugging in the track width across the front, the 57.2958. I remember many webinars ago that somebody asked what that question was, and I blanked on it, but that is converting radians to degrees. We, in our math, we like to use radians, and then at the end you and I understand that this is 20 degrees or 10 degrees. So that's what's converting there. I want to take a minute and share this book right here. It's a practical guide to race car data analysis by a fellow by the name of Bob Knox. Some of you, many of you have this book. A lot of what I'm talking about here, as far as some of the processes, is very, very well defined in this book. If you don't have this book, drop me a note, or just do a search for the title. And Bob Knox, he sells these books. This is one of the, I really, really enjoy this book. We probably ought to get, thank you, Matt. Matt put it up there in the link in the chat box. It's out on Amazon, Practical Guide to Race Car Data Analysis. I like this book a lot. And a lot of what we're talking about here is straight out of his chapter in how to understand suspension. He did such a great job of explaining it. So I wanted to give Bob a nod for that. All the other books do a good job of it as well, but that's the one that I learned on a lot, was out of Bob's book. Okay, so this formula is right out of his book. So so we can get the front roll, we can get the rear roll, and this is all based on now the suspension position. We're adding that all the way out to the suspension. Again, everything being based off the pot itself internally. roll, pitch, all of these different things that you might want to know, not just by looking at it. Let me cancel out of that. Not just by physically looking at what the sensor did, but maybe you want some math. And so that's the math end of it. There's a whole lot more to the the questions you might have or something, but I feel that we need to go through some of that, or this next step is will be bad data in, bad data out. Okay, just all of us just need to be aware. And if you don't have them now, and you're going to get maybe some suspension sensors in for your AIM devices in 6 months from now or something, or over the winter, give me a holler. Let's sit down and walk through your process, your specifics. More than happy to help you walk through some of these things. We're planting the seed for some of you that just to know that there are issues there that we need to cover when it comes time. Okay. The next thing that we want to do, though, is let's jump into where most of you wanted to go, which is the suspension analysis function. We have a function inside of the software, and it's looks like a little shock absorber. You could hit Shift F5 to get there. You can come up into the icon suspension analysis. What I want to do is come over here to the user profile. I've just saved one that's with all my settings just to make it a little bit easier. This is kind of what that screen looks like. Here are these are called histograms. They're an important part, and if what I think I'm going to do in the next day or so, I've got some documents that I have just found on the internet that explain how these histograms read, maybe a little bit more detail into the actual tuning, not just the function inside of Ray Studio. I'm going to plug all those into a single folder, zip it up, and I'm going to put it into the description box below as well. So you'll have another link there when I can stick all these together. Just some good reading material to understand maybe a little bit more of some of the stuff I'm going to touch upon. Here are your 4 histograms. These are suspension speed histograms in basic mode in our suspension analysis. I'm going to show you the advanced mode in a moment. But this is kind of probably where you'll start. And this is what this is telling you is how much time you have spent. And if you hover over one of these and I click on it, you'll see that 15.99% for that bin, maybe we'll call it bin, 15.99%, the shock shaft was in between -5 millimeters per second and +5 millimeters per second. So that middle one, if you look over here way to the left, I don't know how good it comes across on your screen, but the 0 on all of these is splitting a bin right here in the middle. And basically that is the super slow motion of the shock shaft. How much time has that shock been either stationary or nearly? In other words, you're just running down the straightaway. How much time did the shock was less than 5 millimeters per second? Very, very slow. Sometimes you'll see that one all of a sudden jump way up in your data. And every once in a while, maybe you'll get a bent shaft or a seal has froze up or something has happened where all of a sudden the car doesn't work until you really hit a bump. What you'll see is this 0 bin will jump way up on 1, right? And when that happens, and you see how this right rear one here, see how this one is quite a bit higher than the rest of them, or other ones are lower. We have to dig into why, but that one there is showing that right rear is staying at that neutral position a lot, right? Maybe that's telling you something. Maybe there's a slight bent shaft on that one, or the seals are bad, or something is keeping it, or something in the suspension is binding it up. Just that's how you start to read these things. Right here in the middle is the super low speed stuff. You'll notice that there's a grayed out area in all of these histograms. What that gray area is, and this is going to vary on different shock manufacturers, that you look at your shocks and you can set this. I'm going to bring up the settings in a minute. But in my case, the shocks that we're looking at here, the low speed adjustment versus the high speed adjustment, happened at 1 inch, 1 inch of speed, right? They're 25.4 millimeters. Anything faster than that, it ends up being a high speed adjustment, and you take a different adjustment on the shock. The low speed stuff, where the driver has all the feedback, where that's what the driver lives in. That's where the driver feels when he starts to turn the wheel, the shock the chassis starts to roll up, that front wheel comes up, the outer one droops. That is almost all in that low speed adjustment. That's where you tend to work, is in this gray area. I'm going to hit the settings button. and show you that that high-low positive transition, again, your shock maybe it happens at 1.5 inches, maybe it happens at 2 inches. Many shocks, I'm no expert, but I see this 1 inch or the 25.4 millimeter is that spot that most of them are. So yours will probably be either 1 inch here if you're working in inch units, or 25.4 millimeters if you're in metric units. All this is really doing is setting up this little grayed out area here, and then doing the math on that on the next step that we're going to talk about. Okay. The suspension end of scale 155 is nothing more than the scaling at the top and the bottom here. 155 on the positive side, the negative side minus 155. And then you have to, and here's that next really important piece, is when you first open up yours, it might even say logger temperature as the channel that you're applying all of this stuff to and creating these histograms. You need to pick the channel that is what you're after. I could have picked the raw potentiometer information, or what's most important for these, typically it's wherever you're putting your adjustments, I wanted the shock position left front. That's why you see that that's the one that we've got up here. Make sure that you apply your motion ratios, anything you need to do to get to the true shock shaft movement, and that's the one that you should have as part of your settings here. You'll notice that it's all shock position. Okay. Then now we've got our scaling done, so we can, if you're an off-road truck, maybe you have to set these at 500, millimeters per second of travel because of just the spikes and what trucks, these off-road or motocross bikes are doing. Road racing, you're probably in this area. Okay. The next thing I want to do is I want to make sure this group percentage is showing, because that is a big piece of where you're going to spend your time here. Okay, so let me exit out of this, and let's talk about these numbers. This is really, now we're getting into the root of it, the shape of these histograms and the values when the software is giving you for the four quadrants of a shock. It's got low speed compression or bump, and it's got low speed rebound or droop, and then it's got high speed of the same compression and rebound. What the program is doing for you here is it's taking and telling you for the amount of data we're looking at, in this case it's one full lap, it's the best lap that he did that particular run, 25.6% of the time you are spending, that shock is spending its time in high speed, in low speed, low speed in the grays, low speed bump or compression. It's spending 25% of its time. Opposite of that, it's spending 39% of its time in low speed rebound. It's spending 15.3% of its time on this lap, and the data we're zoomed in on the high speed compression, and 20% on the high speed rebound. Okay. Now we're going to talk about, there are a lot of people that do a lot of different things, and an oval track car might be different than an off-road truck, but many of you here are road racers, turning left and right, and cars that basically are set up square to turn just as well left as to the right. The basic numbers you probably shoot for when you first start this, in a perfect world, you would have 25, 25, 25, 25. Every time you get back to the start finish line to begin this lap, to end this lap and begin the next, your shocks and all of the settings are probably right back to where they were when you were there at the lap previous. So as you're traveling around, you really do want your shocks to more or less control the car. You will find some tweaks here and there that will make make the driver feel better or something, but a great place to start is a balanced amount of compression and rebound, both low speed and high speed, and that's where you might want to start. As you can see from this left front corner on this car, on this lap, the car is not spending a whole lot of time in high speed compression or bump. It's only 15% of the time is it up there. 25%. We have in this particular case, we would probably want to allow a little bit more shock movement, take away a little bit of compression dampening on the high speed, allow that car to move a little freer there and not just stop the tire when it gets to that spot and not be as compliant. It's probably a little bit over shocked or over compressed here on the top. And the alternate of that, or the opposite of that, is here on the rebound on the low speed front, right? The on this left front tire, the high speed rebound, it is spending a lot of time moving up and down, you know, especially on the rebound side, the droop as it's happening too quickly. 39% of the time, this thing is spending its time in rebound. What we probably would want to do is give it a little bit more low speed rebound control, where you would then get this number down where it's not just maybe some wheel hop or some chatter in this front tire. And we would probably want to allow it to be a little bit more here in the higher speed stuff. When we change that number, this one transitions. Of course, we're talking low speed, high speed. There isn't a definite wall there. There is some crossover, obviously. But that's a basic idea of how to begin to read these numbers, okay? Does playing with the shock knobs change 25, 25, 25? Absolutely. That is what your shocks. Maybe you have a shock that, there's 1, 2, 3 way adjustables, and every shock is different. But if you have the ability, you would begin to want to adjust the knobs, the compression, low speed compression, high speed compression, low and high speed rebound, to try to begin to adjust these in to that 25% across the board. And you not only want it across this shock, but then you want all 4 of them to be at the 25s on all of them in this great starting shock tuning area. There are all sorts of ideas how to do this. I'm just giving you the basics to start to kind of chew on this topic a little bit. And then at the end of it, maybe your driver just says, hey, yeah, engineering wise, you've got this thing designed with these 25% numbers, but the darn thing still won't turn in correctly. I really want a little bit more, rebound or compression control on the front and a little bit less on the back. And then you just build it in, and that's what testing is about. That's what notes are all about. That particular driver, those conditions, that track maybe likes, 35%, on the high speed rebound. You need to figure it out. This is just giving you the numbers. Go back out, make a change, come in and look at what your numbers were. Okay. Shock tuning is if it was easy, everybody would do it. We'd all understand it fully, and we'd all be doing it, right? There is some information here to play with. Okay. The Joe mentions a question that has just popped up there. On a 3-way adjustable shock, do you want the numbers to be 33%? No, that's the way that our software is breaking it down is only into the 4 quadrants. Your 3-way adjustable shock is allowing you to adjust across the 3 different positions, low speed, mid, and high speed. But our software is just going to give you this, so you will then be adjusting and getting the low speed, high speed dampening here. There are some other ways that we could look at some histograms and break them down into those thirds, but a little outside of what we're going to talk about here today. Okay, we can build our own histograms with our histogram builder, right, up here. Apply that data, build the bins that you want, and then look at it in the 1/3 so it matches your shocks. But this is kind of an industry standard of looking at low speed versus high speed. Okay. The other thing I wanted to make sure we chatted about before I go into the advanced is this concept we've talked about a lot in Race Studio 2 and many of our other webinars, is measures graph is boss. And what we are viewing in the measures graph is what we're doing the math on up here. Okay, that's why I have the screen made up here instead of having this just maximized, which we'll do it just so we can get a better look at it. But I wanted to have this down here, and let's say your driver is telling you that this corner here, and I just clicked into the GPS map down here in the corner. Let's say this corner he's having some handling issues, and you really want to study that corner with some more detail about what the compression numbers are, the rebound numbers, low speed, high speed. The way that you do that is always come into the measures graph and start to zoom in on just that particular piece, right? And then you can zoom in at whatever level, I'll just stop there. Now the histograms that we're seeing are only being applied to the amount of data we're viewing in the measures graph. Continue to zoom in, maybe this is the part of the track that you really want to study. We can pull this back and forth to look at where the braking happens. I've got a lateral G, so I can see exactly where he starts to turn the steering wheel and turn in. You could have shock pot data up there as well. You can see here that he's probably hitting the brakes right about in here, and he starts to turn in right about in here. And now all of a sudden we've got our left front, left rear, right, all of our suspension speed histograms based on just that one corner. Okay, keep that in mind always, and there's tons of different functions inside of Race Studio that follow this same general basic idea. Measures graph is boss. Whatever data you're looking at in the measures graph, if I zoom back out, you'll see those histograms changing shapes and the numbers are changing. It's because we're reviewing what's down in here. If I want to take both laps of this qualifying session, I would hit, again, we've talked about these in other webinars, hit the snap function. We're no longer snapping to a lap. And now I can come out here and I can zoom out and grab the entire 2 sessions, the entire 2 actual laps. The out lap is not gathered because he was just getting up to speed. I'm looking at the entire 2 laps worth of information here, and then not getting the in lap as he came in. And now these histograms are a good sized chunk of data. 2 of these 4-mile laps, 8 miles worth of data that I'm now getting even a better average of the information if you're looking for the overall. So that the snap function, the measures graph is boss. I just wanted to make sure we kind of covered that again in this webinar. Okay, I'm gonna turn the snap off. We can now we're looking back at just the single lap. Okay, this was the basic mode. I suggest you start here. The settings are fairly basic. I brought those up just a moment ago. We pick the data channel that we want to apply. You want the shock position, not the shock pot or not the wheel travel, but the shock itself. You scale it. You tell it where are your transitions from your low speed adjustment to your high speed adjustment. You do that for the front of the car, the rear of the car. If you have selected a motorcycle as your vehicle type, you'll just have a single front and a single rear. Where up here under file preferences and vehicle, can't see it right now, but those are setting, a lot of the settings in some of your in your settings box like this. If you had selected a motorcycle, you would just have a front fork and a rear shock, and the settings would apply to that. I have selected a sedan, which is what this car was, so we're getting sedan kind of values. The analysis options in basic, you can all of these on top of each other. Let's do that. Just to me, it's not terribly wise, right? You end up with you can change your colors and you can kind of see them and you kind of get an idea of what is happening there, but it's not a good amount of information there for me. You can separate the front from the rear, where now the 2 fronts are together and the 2 rears are together, if that's an option you like. Left sides on top of each other, right sides on top of each other. If that's something for you. I happen to just almost always I just jump in here and separate out and use the separate all functions. So just so I can see what the left front is, puts them in the corners that you would expect. Okay. The one set for the weekend, do shock settings tend to hold for the next track next week? Certainly the settings tend to hold. The shocks are pretty robust. Obviously they're being beat up and down the track. You're not going to change that shock a ton by have it being bolted into the, strapped into the trailer and the trip back to the shop and then back to the next track. But the track will change. If you go to Lime Rock one day and you're at Daytona the next, or Pocono, something that's got some roughness to it, you may need to adjust your shocks to get these numbers in there. So it's more track specific than week specific. So Andrew, is the velocity that the high speed, low speed transition occurs at a function of suspension travel, or is it fairly consistent throughout the jumps and rebound? It is more or less what the shock is set up internally. The shock has, if it's got adjustments, those adjustments apply at certain speeds, and your low speed will be in your shock information that you get from the company that built the shocks. They will tell you that low speed adjustment only affects stuff up to 1 inch per second of travel, or whatever the number happens to be. I think that's pretty typical though. That is what what you're adjusting is what the shock manufacturer is talking about. And again, that's why it's so important for you to come from the pot, the potentiometer, with your either mount the pot even Steven with the shock, so they're mounting, you know, it's 1-to-1, or do that motion ratio, so then you really know you know, where this is actually hitting. If I were to have not applied that motion ratio correctly, I would be getting some false transition numbers, and I would be adjusting the high speed when the low speed probably is what I was shooting for. That's why we do that. Okay, in the settings, you also have, and we're you know, only 5 or 10 minutes away from the end, but you have an advanced tab. I suggest you stay here in the basic tab for a while, but if you hit the advanced tab, I'm going to exit out of here, and I've just saved a, you'd have to restart the function, but I've got a advanced tab where I've created one. It's going to look virtually exactly the same to you from your eye right here. The cool part though about it is when you go into the settings under the advanced, you have the ability to do a lot more. Again, we're not going to be able to get into a ton of this, but you have now the ability to go in and adjust not only one, you know, fronts and backs, but every single corner. You can pick your shock, obviously. Here's that transition rate we've talked about. You know, position top and bottom, we're going to see that in a setting I do in a moment. There's that same 155 setting, this scaling. This position top and bottom is there because we can do a suspension position in this particular graph. Hey, this is exactly like we looked at in our when we first started, right? We can also come in and this gets pretty busy pretty quickly, but we can do some pretty interesting things. I just clicked on all, and if I apply an exit there, now you've got your histograms for now. This entire these 4 panels are all the exact same shock. We're doing a suspension position. We've got velocities in this little window. We've got our position frequency graph and our histogram all for the left front tire right here in front of us. It's pretty darn busy. I'm a big fan of doing each of those individually if I want to, but these are the kind of things that the advanced mode gives you the opportunity to come in and change some of those things. I'm going to go back to the histograms because that's where most people will be working. We also have the ability to define our springs and our damper forces by plugging in some information here, and we can come in and build some tables where our damper, you know, sensor linkage ratios. There's some real power in here for you if you need that. And then under the histogram, we've got some other settings here that we can negative and positive together, smoothing, some normal distribution curves. We can actually put those right in there, show the average values, apply and exit. Let's get back to kind of the standard look, but all of those under the advanced settings if you wish as well. Okay. That's the basics of where we are, what I think I wanted to cover in today's. And I think we got through a lot of the questions. We're getting pretty close. We're probably gonna have to start to roll this out right now, but hopefully we've given you an idea of the suspension analysis. I want a little bit of feedback from you. Andrew has a question there. Can you do dynamic roll center math channel using 4-corner shock pot suspension geometry measurements? Andrew, that is a great tie-in to about 2 slides from now. Let's hold that question there. Emiliano, you can either leave it there or you can pull it out. And let's talk about a math channel doing that in just a second, because it's going to tie right into next Tuesday's webinar. Hopefully we've given you an idea of what you need and what you want and how the basic function works. I know a lot of you do not have shock sensors on your car. This data right here is available for you to download. Again, MX5 Cup data, Miller Motorsports Park, Utah Motorsports, outside of Salt Lake City. It's a couple of qualifying laps and an in and out lap on each side of it, so it's fairly small where you can tinker around a little bit. That data is available for you as part of links that Emiliano has been nice enough to put in the chat box. If you're watching this on YouTube later, it's down in the description box below. What I've done is I've given you not only that, but also the to get the channel order right and the math channels, everything with this and these user profiles. You can upload these as well to look at your data exactly like this. You can go back and take a look at play back the video and get that information. Hopefully the sample data allows you, some of you that don't have shock sensors yet or considering it, to go in and start to kind of use the functionality and start to understand, is it something that I might want to use, might want to add to my race vehicle. Again, doesn't matter if it's a sports car, motorcycles. Some of you in carts probably don't have a lot of interest in this, but everybody else, maybe it's something you might want to work with. Okay, let's jump back into the presentation and kind of start to close this out a little bit. This video, along with all the rest of them, gosh, we have 112 videos when we include this one up here in just a few minutes. That LearnFast e-training video site is just fantastic. There's a lot of all of the webinars, obviously, and this is number 46, I think, something like that. Yeah, number 46. Plus, there's a ton of functionality style of videos that are up there. They're a little bit older, but you know, the function hasn't changed, right? Lap insert, sorting channels, some of the stuff you see me do is all, we have tons and tons of information like that. Okay, the next thing talking about customer support, I've often said, and I say it all the time actually in the seminars, and I've said it here a number of times, we're really a customer support company that happens to sell racing electronics. Our dealers, AIM Italy with Emiliano here joining us so often, again, many of our dealers, we're here to help you. We realize this is not just a plug and play, device. You need a little bit of help making sure that it's getting up and running and that you're getting the most value from it. Give us a holler. Look for us at the tracks. Let us get you answer any questions you have, so you just don't get too frustrated. Many people don't, but if you need something answered, give us a holler. There's the 800 number. You've got my email address. Reach out and let's do that. Here is the next one. Here is what we need your help. This is a little bit of a different topic. Yes, we're going to talk about math channels, and we did that, the power of if, and we've done some basic ones. What we're really looking for here for next Tuesday is your help. What are some math channels? I think Andrew, you came up with a fairly complex math channel. That's exactly what we're looking for. This is not only to help people understand how the math channel works in Race Studio 2, but we are, Emiliano, not me certainly, but Emiliano and his team in Italy, the software team, are actively working right now on the math channel function in Race Studio 3 beta. It's mostly there, but of course we want to make sure things are working the way that we want them to work. You please share with us. You don't have to share the math channel itself, because if you knew how to do it, you probably wouldn't need the question answered. But what are some math channels what are some things you would like to do with math channels? Maybe something you've thought about, you've never been able to complete it, get it done, make it work correctly. I know I've gotten a new user here has been chatting back and forth with me the last few days with a math channel. That one's already been turned in. We'll talk about that one maybe on Tuesday. Emiliano is going to take him and his team, and they're going to look at your data really at two different levels. Let's write that very, very difficult, very complex math channel in Race Studio 2, test it out, make sure it works, present it to the entire group on Tuesday. If you have some other ones that you just haven't been able to get to work right, or you've thought about some interesting things, send them to me. Send them to me, send them to software@aimsportline.com. If you send them to me, Roger at aimsports, we'll certainly get them over there. And then that will also then transition into Race Studio 3 math channel functionality to make sure that the stuff that you want is what we're building into that functionality, and some shortcuts, and makes easier to do. So please, all of you that are watching, we've got a good number of people out there have watched this suspension analysis webinar. Send us your math channel ideas, some tough ones, some you haven't been able to figure out, or some things you've been thinking about for a number of years. And boy, if I could do that, that would be kind of cool, right? If I just every 1/10 of a second all through my data, if I knew what the camber was on my right front tire, right, because of suspension travel and knowing the camber rates, whatever it happens to be, throw some out here. We'd love to be able to create those and share those on Tuesday. So think about those. We appreciate appreciate all your help in getting that ready. Emiliano has been bugging me a little bit. The last 3 or 4 weeks, he's been asking for this particular topic, and I thought it would be a great time to do that. So give us your ideas. Again, thanks everybody for coming. Thank you, Emiliano, for being here and manning the back end of this and taking care of lots of questions and answers. I appreciate that. Here's my contact information with those math channels. Please make sure we want to do this on a Thursday to a Tuesday to give you guys plenty of time to send us that information, so that that next one will be next Tuesday, and so we have a little bit of time. We need them as soon as possible. Don't send them the night before. So we're trying to put something together. Send it to us. My email address is right there. I appreciate everybody coming. These are great fun for us to do. It's educational. It helps the entire user base, I think, with these, and of course saving them on YouTube where everybody can watch them in the future is a great thing. So thanks everybody for coming. Looking forward to Tuesday, and hope you guys are able to go visit a track or go work on your cars and have a good time. So thanks everybody for coming. We'll see you on Tuesday.